All right, so number 7. Can you guys find number 7 in your warm-ups, please? This one, can you tell that it doesn't have y equals? So we do the x and y intercepts. Okay, so over here, right, x-intercept, y-intercept. And do you guys know what to do when you have an x-intercept? Oh, I heard it. Y is 0. Yeah, okay. So you set y as 0. And do you know what to do when you want a y-intercept? You set x as 0. Okay, so we're going to do this 2 problems. We're going to first put a 0 in this spot. So x plus 0 equals -3. X equals -3. And that's the coordinate -3, 0. And we're going to graph that over here. Okay, and then y-intercept, we're going to put 0 in the x spot. So 0 plus y equals -3. Y equals -3. So that's the point 0, -3, which is down here, 0, -3. And then draw your line. Good. Okay. Now, write the slope-intercept form of the equation of the lines to the given points. x1, y1, x2, y2, m equals y2 minus y1 over x2 minus x1. -1 minus 3 is -4. And what do I do down here? Plus. Which one of the coordinates do you guys want to pick to be x and y? Yeah. Do you guys see that they actually gave you b in this problem? But we're just going to do it because a lot of times they do that and people just don't realize it. They just go through the motions, which is totally fine. Do you guys see where I got the -1, -4, and 0 from? Are you sure? Here's the -1, here's the -4, and there's the 0. Okay, final answer, y equals -4x minus 1. Okay, here is our agenda. 61, 62, and 64 are all in the packet. So if you could find those problems, 61 is the shapes problem, like shapes page. So find the shapes page. 62 and 64 are on the back side of the shape page. And then we're going to work on the digital escape. As I said, it's spicy. And you're going to want graph paper for it. I put graph paper on your tables so we can do that off to the side. Homework is a worksheet in your packet about parenting relations. And here's my joke. It said to put it in the oven at 120 degrees. So, do you get my joke? It's like degrees. I don't know how you'd put it in the oven at like 350. That'd be upside down. Okay. So if you do not have a straight edge yet, grab one for number 61. Okay, and what we're going to do on number 61 is we are going to draw in all of the lines of symmetry for these shapes. Okay, so we're going to start with the hexagon. If you guys are good at this, you can go faster than me, but I like to draw them in as dashed lines. So I'm going to draw in all of the lines where if I folded on that line, it would match up on both sides. So I'm finding all of the lines of reflection. Hexagon has a lot of them. I like to rotate my paper as I do this because it makes the lines of reflection easier to see and draw. Can you guys already tell how many it's going to have? Okay, if you're confident in this concept, just keep going. I'm just going to go at my pace. But if you're faster than me, feel free. The kite is weird. The kite feels like it should have two, but it actually only has one. Oh, and I really should draw it actually through the corner, so that'd be good. How many does a rectangle have, you think? It actually only has two. Does anyone feel like the corner to corner one should be lines of, let me show you why it's not. Let me do this. So I'm going to take a Post-it note and make it into kind of a rectangle, same as this. And let's say that I fold it. Watch up here. I'm folding it from corner to corner. What happens? Like this far corner doesn't fold onto the other one. It folds down next to it. You guys got that? So it feels like it should be able to have diagonal ones, but it doesn't. How many does the scalene triangle have? None. That one's done. How many does the trapezoid have? None. That one's done too. Okay, equilateral triangle though. Square has 4. That's where the difference between the square and the rectangle comes in. Oh, I thought you were going to sneeze for a second. Okay, what about the isosceles right triangle? Do you guys know what isosceles means? Two sides equal. And right triangle means there's a right angle here. How many does it have? 1, right down this way. Any questions about the top 2 rows of these fantastic shapes? You guys all good? Anyone want to argue with me? Any of the lines of symmetry? I think we did it. Okay, here's a fun question. How many lines of symmetry does a circle have? Infinite. Yeah, and I'm not even going to draw them. You know what I'm going to do? There's all my infinite lines of symmetry colored in. I don't know about you, but I find it really satisfying to watch someone color something in on the screen. It doesn't have to be me. Just like whenever I watch someone do that. Problem is with this particular pen, it can't be perfect. And I like things to be perfect. Okay, moving on. How many does a rhombus have? It's actually only 2. Rhombus has the same issue as a rectangle, where if you were to fold it on the diagonal ones, it would not match up. Of course, you have to actually go through the corners. What about this janky quadrilateral? Nothing. Isosceles triangle? Just one. Okay. Scalene right triangle? Nothing. Isosceles trapezoid? One. Okay, here's a fun question. Parallelogram. Nothing. Regular pentagon? Five. That one was slightly poor, but it's fine. We're just gonna move on with life. That would be great. Didn't turn out too bad. Okay, so that was problem 61. Now flip the page over. I think this is the ugliest resource page known to man, but I was just too lazy to retype it. Okay, examine the diagram above. Is it a polygon? So let me actually define a polygon for you first. A polygon has all straight edges that all connect and do not overlap anywhere. If they have all straight edges that all connects and doesn't overlap anywhere, then yes, it is a polygon. Why am I over here? Oh my gosh, I'm so old. Oh, okay. Okay. Can this figure be rotated onto itself? Trace this shape on tracing paper and test your conclusion. If it is possible, where is the point of rotation? Okay, so while we're tracing this, I have a question for you. What car logo is this? Is this a car logo? It is? I thought Mercedes was like 5 points star. No? Oh, it's missing the aha. You're right. You're right. You're right. Dylan, you're so chivalrous. Okay, so trace it. Okay. Trace this shape on tracing paper and test your conclusion. if it's possible, where is the point of rotation? Okay, so trace it first and then rotate it. Ah, yes, it can be. So where's the point of rotation? You think somewhere like right here? You can test it out by holding your pencil down there. Seeing how close, mine's a little off. Ah, that's better. Sign me up for surgery, boss. Okay, so where is the point of rotation? So, oh goodness. Okay, now I have to try to put it. Okay, now I have a question. How many degrees does it take to rotate this thing onto itself? So do you guys notice that it matches up 3 times? So one turn, this is a third of the way, 2/3 of the way. Yeah, and then all the way. Okay, great. So how did you get the 120? So 360 is a whole circle, all the way around is 360. And it matched up 3 times. So it matched up every 120 degrees. So it's 120, 240, and 360. Jessica claims that she can rotate all polygons in such a way that they will not change. How does she do it? How can you rotate everything? Yes. Yes, rotate 360 or any multiple of 360. So 720. What's the next one? 1440. Where's my skateboarders? They always know all of the multiples of 180. Wait, so start at 180 because 180, 360, 540, 720, right? Okay, since all polygons can be rotated 360 degrees without change, that is not a very special quality. However, the polygon in part A above was special because it could be rotated less than 360 and still remain unchanged. A polygon with this quality is said to have rotation symmetry. But what shapes have rotation symmetry? Examine the shapes on your 3.1.5 resource page and identify those that have rotation symmetry. Okay. So the question is, if I rotate my paper, if I turn it, will it come back to the exact same picture? So we're looking at the hexagon. If I rotate it, will I get the same hexagon? Yes. Okay. So this one, yes, has rotation symmetry. Does this one? No. And we're not going to figure out all the angles of it. We're just answering yes or no here at the moment. What about the rectangle? Yes. No. Talia's on fire. Good. It's good. Okay. What about the trapezoid? Nope. Equilateral triangle? Yes. Square? No. I don't think so. Okay, hold on. Okay, so here's my, okay, So here's my original picture. If I rotate it around, am I ever going to get this exact thing? Hold on, it's hard to do with the camera. Nope, sadly. Circle? No, yeah. That's the best one. Rhombus? Yes. Quadrilateral? No. Isosceles triangle? No. 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 What about the parallelogram? It's my favorite. Yes. And you can test that by turning your paper upside down. So take your parallelogram, kind of like burn it into your eyes, what it looks like. Same thing. It's my favorite. Regular pentagon. Yes. Okay, now flip back over to the other page. E, last one. What shapes on the resource page have 90-degree rotation symmetry? That is, which can be rotated around about a point 90 degrees and remain unchanged. Okay. Does the hexagon work for 90? Let's just look at it. This is 90 degrees. Is this still the same hexagon we started with? No. Same kite we started with? No. Same rectangle? No. We don't even really need to check the ones that we already have no on. Ah, square? Finally. Circle. Really was just the square and the circle? That was it? Okay. Okay, now last thing for this before we start the spicy digital escape. Okay, 64. So we're gonna do two things on 64, three things. First, we're gonna name the shape. Okay, can you guys count the sides? How many sides does this shape have? 10. Okay, 10 sides. What do we call a shape with 10 sides, Tice? Decagon. Nice job. Okay, does this shape have lines of reflection? So lines of symmetry. Could I draw a line? I don't want to do it. Okay. How many lines of symmetry will this have if I draw them all in? I don't want to draw them all in. But how many would it have? Give me a guess, a theory. 20. Can you guys tell that there would be 20? Okay, so let's draw like a couple of them so we can see. Can you guys tell that there would be one? Actually, no, you're right. It's 10. No, wait, I don't know. I think it's 10. I think you're right. Because every two corners counts as one. Okay, so there's one of them. Okay, so how many quarter to corner ones will there be? 5, right? Okay, and then if you go down straight down the middle, so there's going to be bound to be 5 of these and bound to be 5 of these. We all agree? Okay. Okay, last thing. Does this have rotation symmetry? Okay. What kind of rotation symmetry does this have? Name me an easy one. What's the easiest one? What do they all have? 360. Okay, what else does it have? Yes. 36. And 180. And 72. And 108. Is that the next one? Do you guys know where I'm getting these numbers from? So, okay, there's 10 sides, right? Are you guys okay with there being 10 sides? Okay, so if there's 10 sides, the whole circle around is 360 divided by 10 is 36. So that means every 36 degrees, it goes back to itself. So 36 plus 36 is 72, plus 36 is 108, plus 36 is 144, plus 36 is 180, plus 36 is 216, plus 36 is 252. You would tell me if I'm like completely messing this up, wouldn't you? Plus 36 is 288. Plus 36 is 324. And then plus 36 is 360. And then really, to be honest with you, it's plus 36 forever. But we're not going to do any more than 360 right now. Okay, this is what I need you to do. I need you to locate your digital escape page. What? Right here. On what? Yeah. I actually gave you guys graph paper on purpose. So locate your digital escape page. Yes. If you can do it yourself, it's fine. Okay. Locate your digital escape page. Go on your computer and bring up the digital escape, and then get that big piece of graph paper. All right, you guys ready? What? No, that's a good. I like it. Okay. Yes. All right. So let's start with puzzle one. These are not easy. I need you to stick with me unless you're just somehow this clicks with you, which is great. Don't get me wrong. I'm just, I just need to make sure. Okay. All right. So the other day, Tuesday, we learned about parallel and perpendicular slope. Parallel lines have the same slope, but different y-intercepts. So same M, different B. Perpendicular lines, their slopes are opposite, so different signs, one goes up, one goes down, and reciprocals. So it's switch the sign and flip for perpendicular. Okay, so that being said, number one, are these the same? No. There's just one that's flipped, but it's not opposite and flipped. It needs to be opposite and flipped to be perpendicular. That one is neither. Okay, so this is what you should have. Okay, so those two fractions, just the reciprocal. It needs to be the opposite reciprocal, but not just the reciprocal. Okay, luckily the next one's easy. Number two, this one, are the graphs parallel, perpendicular, or neither? Number two, parallel, because they're going the same. So you guys okay so far? Okay. Okay, now number three. You're only looking at the slope. They're going to have different y-intercepts. That's totally normal. But you're looking at the slope. Are those slopes the same? No. Are they? Are they opposite reciprocals? No. They are reciprocal. They are not opposite reciprocals. One of them needs to be negative and one of them needs to be positive for them to be opposite reciprocals. Okay, so knowing that, look at the fourth one. Are those the same slope? Hold on. I'm asking a question. Are those the same slope in number four? You're saying 2/3 is the same thing as -3/2. No. I said, are they the same? Are they the same is my question. No. Okay. Now, are they opposite reciprocals? Yes. Okay. So number three is neither. Number four is perpendicular. Okay. Did you guys get out of the first one? Did you get out of the first one? Okay. All right, when you're ready, go to the second puzzle. Okay. Oh, I gotta do my little thing. All right, so we're gonna do a couple things. So we're gonna do this on the sheet and the graph paper. Negative 4x plus 2y equals 8. Okay, do you guys remember what we did in the warm-ups with the x and y intercepts? Okay, so that's what you're supposed to do here. So you're going to say x equals 0, y equals 0. And the first thing you're going to do is put 0 in for x. So negative 4 times 0 plus 2y equals 8. Two y equals 8. What does y equal? 4. Okay, so what is that coordinate? 0, 4. Okay, what I want you guys to do is take the piece of graph paper that I put in the middle of your table. It's like you guys know how to do all the parts of this, but putting it together is kind of challenging. Okay, so 0, 4 is right here. Okay, now I'm going to do my second part where y is 0. So negative 4x plus 2 times 0 equals 8. Negative 4x equals 8. What is x? Negative 2. Okay, what is the coordinate? Yep, negative 2, 0. Beautiful. Okay, so you take that information and you come over here to negative 2, 0. Okay, what is the slope between these two? Okay, now tell me what is the slope of these two? Okay, now we go back to the digital escape. Once you have your slope calculated over here, back to the digital escape. And the question says, find an equation that is parallel. Okay, so what you're going to do is look over here at the answer choices and find me one that has the same slope. Which box has the same slope as the one I found? Yeah. What slope did I find? What number was it? 2. Which one of those has a slope of 2? D. You guys see the 2 as the slope in D. Okay. Go down to your code and write D. luckily they're not all that bad. But the next one that we're gonna do, not the next one, but the one after that we're gonna do together is really, really spicy. So hold on for that one. Okay, now the next one's not too bad because I haven't really zoomed in, especially what is the slope on the graph on number 2? What's the slope here? Rise over, okay, but it's negative. You guys need to find the negative. You're gonna have to figure out how to remember it. I don't know what to do for you there. We've done it a million times. So you guys are gonna have to start remembering. Okay, so the slope in that is 1/3. So you're gonna write slope equals negative 1/3. What would the perpendicular slope to that be? Positive 3/1, which is 3. Beautiful. Flip, switch the sign. Okay, can you guys find me an answer choice? Yes. Are we getting it? Is it happening? Okay, I want you to try number 3 yourself. So it says find an equation that is parallel to this. So you're going to find the slope of that. Write it down. It says parallel. So you're going to look in the boxes for one that has the same slope. Okay, so there's this. What's the slope of this one? 4. Can you guys all tell the slope is 4/1, which is 4? Okay, now, which answer choice is G? Okay, so this is how I want you to write it. Hopefully this is how you wrote it. So this is slope is 4/1, which is 4. And the parallel slope to that is also 4, which was equation G. Okay, now we're to the spiciest one of the whole digital scape. Okay. Of course, my box is not going to have enough room, but you know, I'm going to do my best. Three x plus y equals 1. So put that up at the top. Notice my tiny writing. Okay. So I'm going to put 0 in the x spot. So 3 times 0 plus y equals 1. Y equals 1. 0, 1. Okay, so come over to your graph paper, and I was just in the process of erasing my previous one, but you can make a new spot because I gave you a whole sheet of it. Somehow I felt that erasing it would be less work, but I'm not sure about that, honestly. Okay, so 0, 1. Okay, that's not really where the spice comes in. The spice is going to come in here. 3x plus 0 equals 1. 3x equals 1. Shh. X equals 1/3. That's really gross. And that's why this problem is spicy. So we need to graph the point 1/3, 0. It's bad. It's real bad. Okay. Now what I want you to do is to make this easier on yourself. I want you to go down 1 over 1/3, down 1 over 1/3. Oh no, it's not linear at all. No, I know. I don't know what to do. Yeah, me too. Okay, bye. No, no, no. It's totally valid. Okay, bye. Sorry about that. Okay, now, did I tell you? Do you want to tell me this? No, the slope is not 1/3. So let's make our slope triangle. The reason I had you extend out the pattern is because I like to do a slope triangle on whole numbers. And I've always told you guys, make sure to find what I call lattice points, actual like whole numbers to make your slope triangle. This one is 3 and 1. Okay, so what is the slope of this? Almost. Yeah, nice. Nice catch. Good job. Okay, so the slope of this is -3. I can't even remember what it asked. Perpendicular. Okay, so what would perpendicular to this be? Yes. Wait, 1/3, right? Okay. So hold on. Did it say perpendicular? Yeah, it did. Okay. So perpendicular slope is the opposite reciprocal. And luckily you have it right here. So you could just flip it. Switch the sign is 1/3. Okay. So which equation? Nice. B. Okay. Unlock yourself out of the second lock. Assuming we got it correct. Did we? Yeah. Okay. Excellent. Okay, puzzle 3 is the same thing as puzzle 2. Scroll down. You can't do this, but find your spot for number 4. So go to puzzle 4 and draw in your 4 boxes if you do that. If you don't do that, it's totally fine. But if you do that, do that. Okay. Listen. We're on puzzle 4 right now. Skip puzzle 3 for the moment. You know how to do that now because we just did puzzle 2. Go to puzzle 4. I know, I'm just saying on your paper, go to puzzle 4. Sorry, I should have clarified that. Don't go to puzzle 4 on your computer. Just go to puzzle 4 on your paper. My fault. I'm able to scroll through it because I'm the teachy. You guys are going to do puzzle 3 in a minute, as soon as I'm done showing you how to do puzzle 4. Okay, we're going to do the first one together in puzzle 4. It says, find the equation parallel to y equals -2x plus 10 through 3, -1. Okay, what is the slope of the blue line in question 1? -2. And what would a parallel slope be to -2? -2. Okay, so you're going to write m equals, and you're right, parallel slope equals -2. And then you're going to write the point x, y, 3, -1. So x equals 3, y equals -1. Y equals mx plus b. -1 equals -2 times 3 plus b. -1 equals -6 plus b. Add 6. Why did I cross that side out? This is why we live in a land of erasable pen. 5 equals b. Okay, so final answer for this would be y equals -2x plus 5. Okay. Which one is that? G. Okay. So your first one for puzzle 4 is G. Okay. Okay. Do you know how to do puzzle 4 now? Okay. Now I'm going to scroll to puzzle 5 and I'm going to get you started on puzzle 5. Just the first one. And then the rest of the period is going to be you working on this and the homework. Just have one more to do. Okay. Puzzle 5. It says find the equation perpendicular to y equals -2x plus 10. Okay, so I'm going to say slope is -2. I'm just going to put it right there. I got that out of the problem. Okay, but it said perpendicular. So what would the perpendicular slope be to -2? Yes, Titus? +1/2. Great job. Flip, switch the sign. Okay, now go back to the problem and get the x and the y. The x is 10 and the y is 7. So you write underneath it, x equals 10, y equals 7. Y equals mx plus b. 7 equals 1/2 times 10 plus b. 7 equals 5 plus b. 2 equals b. Y equals 1/2 x plus 2. Okay, which one is 1/2 x plus 2? B. Excellent. Okay, so come over here to your little code. First one is B. Okay, do you guys think you have all the tools now to be able to finish this up? You have one of each in each thing, but puzzle 3 is just like puzzle 2, so you're gonna have to look at puzzle 2 for puzzle 3. The rest of the period is independent work time, so you can put headphones in and things, totally fine. Just finish this up as best you can. I think I put it due on Monday, so if you don't finish it, you can work on it in Access and stuff. Alrighty, and you guys all know what the homework is, should I show you? Yeah. Okay, the homework is the next page in the packet, transformations practice. Use your tracing paper, it's gonna be awesome. I'm gonna leave this up here though for you.